Okay, 34, it's a good problem. Now you look at this and it looks like a kinematic problem, which it certainly could be. You learned back in chapter 3 how to solve for different variables for projectile motion. So what this question wants us to find is the maximum height that this projectile reaches if it's launched with a velocity of 40 meters per second at an angle of 60 degrees. But we have to do it with conservation of energy. So how could you do this with conservation of energy? Well, let's first set our 0 point. So 0 point pertains to potential of gravity. Let's make this our 0 point. Down here is where h equals 0. So what type of energy does the ball start with? Only one. Kinetic. So we have kinetic initial and no potential of gravity because it's on the 0 point. Then the ball goes up to the highest point. This is our final. We're using this point as our final because that's where the maximum height is. What type of energy does the ball have up there? Well, there's two. We have kinetic plus potential of gravity because it's above the 0 point. Now, were there any non-conservative forces, so any force other than gravity or spring that did work on the projectile as it went from here to here? No, so this is purely conservative, so we can say mechanical energy initial must equal mechanical energy final. So what was our starting mechanical energy? Our starting mechanical energy was in the form of kinetic. What was our ending mechanical energy? Ending mechanical energy is kinetic plus potential of gravity. Okay? So, now we plug in our equations. What is kinetic energy? Kinetic initial, we're going to say 1/2 m v initial squared. Kinetic final is going to be 1/2 m v final squared. And then potential of gravity is mgh, and h is what we're looking for. Now, do we know v initial at the beginning? Yes, v initial is 40 meters per second. What is v final at the maximum height? Is it 0? Is the object stopped up here? No, but what do we know about its velocity at the highest point? The velocity at the highest point is only what? X. The projectile is going to have a velocity, but it's going to be in the x direction. In other words, Vy is 0. Okay? So do we know what this Vx is? Not yet, but we can get it, because what do we know about Vx? It stays constant. So down here we can get the Vx right here, right? We break this into components. So Vx is going to be cosine 60 times 40, which works out to be 20 meters per second, which is the velocity at the highest point. So this is 20. Oh, and then also notice they did not give us the mass of the projectile. The mass of the projectile was not given because what happens? It cancels out. It doesn't matter what the mass is. Mass drops out, and now you get this equation, 1/2 v initial squared equals 1/2 v final squared plus gh. So remember how we said this was, you could solve this as a kinematic? Does this look familiar to you at all? Look at this, v initial squared, if you multiply through by 2 to get rid of the 1/2, multiply through by 2, v initial squared equals v final squared plus 2gh. What is that? That's the fourth kinematic, which looks a little different because it's kind of, this should be, if it were a kinematic, you would want this to be minus, but where would the minus be if you were doing a kinematic? The minus would be in the form of what? Of gravity. So it is a kinematic. So basically now what you do is you plug the numbers in, solve this for h, and h comes out to be 61.2 meters.